Hello everybody, this is Paul Pace, and I'll be showing y'all a paper review on a novel hybrid genetic algorithm with granular information for feature selection and optimization. This paper is focused on a few unique elements. This is just an overview of the assignment itself, but we'll go ahead and hop right into analysis. This paper is specifically focused on feature selection for big data analysis, something that is a larger issue overall with data analysis today is that we have a lot of data. And there's a lot of correlation, there's a lot of causation, there's a lot of related elements that we're trying to understand. These are called features when you're working with machine learning and even with genetic algorithms. For pretty much any set of data, you have 2 to the n possibilities of different feature selections because you essentially, a lot of times, we treat it as on or off. But this paper takes a approach that's basically granular. So it takes pieces of it, not all of the data, but components of that, to allow for more flexibility. And it's used to optimize the networks as a whole because sometimes a portion of a data set is useful, or a portion of a feature is useful, but not all of it for your data analysis. It then further uses genetic algorithms to find the most optimal granular solution for in the quickest manner. That's their whole goal, is to really research and see if they can eliminate the human element from feature selection and do it faster than a human could. And they have other algorithms that they show. So they show 3 unique algorithms, and here I just list out different attributes of them. But the major one that they show is here on the end, the ROGA, granular optimization of neighborhood rough set based on genetic algorithms. This is a combination of the INRSG and K nearest neighbors genetic algorithms. So its big O is straight up a combination of those two. INSRSG isn't actually a genetic algorithm though, sorry. It is just a normal algorithm, and it's an improved neighborhood rough set with some granulation for feature selection. I didn't come up with these names. Don't like them, but we have to lump them. So their focus is not necessarily just on the quality, but also on the speed, because what the issue is right now is it's taking large amounts of time for people to select the features from these massive data sets that we're getting from places like Google, TikTok, other major information sources such as the metaverse. And as these grow larger, we're trying to find correlations and adjustments and fine tune how we're selecting features to improve machine learning characteristics. It's useful in doing scientific research, so on and so forth. So the one that they primarily are trying to present is this ROGA. It uses actually a variable length chromosome that's solely based on the precision that you want the solution to be, which is basically how narrow of a subsection of the features do you want, how tight do you want that to be, and so on. And they found some pretty interesting results. Basically, the ROGA was highly accurate. It was able to, it was really good with selecting smaller feature subsets, and had higher accuracy than pretty much anything else. They used a variety of different sets of features. One of them was related to cancer research, and they had some other ones because again, their focus wasn't on actually solving a specific problem, but rather solving the problem of feature selection so that you can pass those features onto a machine learning system which can then make a better prediction. And so this is to help on that prediction pipeline that's commonly used. So the biggest thing was that they are now able to obtain granular parameters without any human interference, and this increases the interpretability of the results. So human interference kind of causes this blindness that basically just blocks what we're trying to talk about and discuss, and can lead to biases in the data. There's the different granularity on the number of features in the average, different granularity on the number of features. So basically, they were able to hone in on different components at different times. So it did show some variability, which is kind of interesting. And it was a successful approach of combining granular computational theory, which they discussed throughout the paper, and evolutionary algorithms for these genetic systems, and aggregating them into a feature selection for large scale data. Once again, this is not focused on just like the cancer situations and things like that. It's for these massive data sets that we're getting and gathering from larger companies, from combining data from multiple companies, and working with that to make better analysis of the overall situation, which could greatly benefit us in the future because it would automate a lot of data analysis components. So my personal analysis on this is, honestly, this is a very intriguing method to use genetic algorithms for. I think it's one of those things that sitting down when I first saw the paper, I was like, this has nobody thought of this, and I realized like I personally haven't. It's a really powerful way of handling feature selection, and I think it's a good way of eliminating human blindness as a whole. Because we as people tend to assume that maybe we need all the data, or we only need these two data points. And having experience with genetic algorithms, I've learned that making assumptions is the worst idea possible. Best case is to take all the data and pray that you can interpret it. But I would say there's some very efficient use of genetic algorithms, and really is kind of this perpetual. I feel like if you could find a way to tie these in together and basically make a loop genetic algorithm such that it either combatively or something else was able to make even more accurate ways of feature selection using genetic algorithms to influence genetic algorithms that could essentially just make an infinite loop of improving feature selection. Obviously, there would be limits, but I think it would be pretty useful. And then here's a reference to this paper if you guys would be interested in it. It will be included in the video description on YouTube. So go ahead and check it out down there. And leave any questions in the Canvas comments or in the YouTube video. But without further ado, I do hope that y'all have a wonderful rest of your day.